But what's interesting is that the application developer wouldn't necessarily need to integrate with the BIG-IP. The application developer would only need to communicate and configure NGINX Ingress controller. These two are somewhat decoupled. What's great about that is that if there's an error out here, or if the application developer, think of it, is scaling or auto-scaling a lot of pods, only the NGINX Ingress controller is seeing it. BIG-IP is completely stable. BIG-IP doesn't see it. BIG-IP only sees the NGINX Ingress controller as its pool members. So BIG-IP is only front-ending the NGINX Ingress controller. If you want to auto-scale your NGINX Ingress controller because of more load, more data, or potentially you want more throughput, then you could go ahead and scale this. Once you scale this, CIS will see it and update the BIG-IP. So this two-tier architecture is being decoupled. And the reason why is potentially to align with the different personas. I'd be interested to see if this aligns and fits with your organization. By the way, some of these might not exist, but I think that's why this Kubernetes engineer, this new title that I'm seeing, is actually becoming more prevalent. So now that we saw the different personas, let's take a look at what IngressLink is. So folks, IngressLink is a kind of CRD. I say it's a kind because it actually is. It is something that F5 has created as a solution. The two components, CIS and NGINX, are independent. Both of these solutions are fully supported. That means that if you roll this out, if you need F5 development support, you can call into F5 support and you can get full enterprise-grade support. Whatever contract or whatever license you have on BIG-IP, or CIS inherits that. And so that's one of the reasons why NGINX Plus is important, because NGINX Plus provides you with your support. If you use OSS, that's fine, but that piece is going to be community supported. But the IngressLink piece is fully supported, and I have seen some, if you want to call it tickets, or some GitHub issues, and those are resolved. And this is an ongoing dev project that is maintained by development and funded. So the IngressLink CRD is created, and both of the controllers are able to monitor this IngressLink CRD. So if you think about it, at the end of the day here, we're just using the Kubernetes API, but both of the controllers are able to communicate across this IngressLink CRD. If you want, and I'm going to show you in a minute, if you want to potentially decouple and remove the capabilities of creating the CRD and just use service type load balancer, that's coming. The IngressLink CRD itself is very uncustomizable. It is that cloud-like layer 4 ingress traffic at layer 4 from BIG-IP straight to NGINX. What is tied in here is BIG-IP will monitor for health the NGINX liveness port or liveness probe. That means that BIG-IP will check to make sure that these ports are up. There's a specific API to do that. If one of the NGINX liveness ports is down, then BIG-IP will remove that from its pool members. How you integrate from a CNI here is really up to you. You can use Calico. You can use VXLAN. So the two traditional options is Calico, which is a BGP based. You can use Flannel or VXLAN. And then if you want to just do routing, you can also do that with potentially something called node port. So either option, node port, cluster IP, those are your two options. And potentially now node port local, potentially, if you want to use that as well for VMware. Those are your options as well. So once the CRD is created, what CIS will do is it will populate BIG-IP with these pool members. What's really great is we talked about this. Anything that's going on here is outside of what goes on here. So this one instance, BIG-IP, will have 3 instances here. When the application developer brings on new services, they're creating a separate resource. This separate resource is of a different namespace, is potentially of a different project. CIS doesn't pick it up. CIS doesn't watch it. And that's really interesting. This is all watched by the NGINX Ingress controller. So all HTTP routing is done here. This is potentially end-to-end SSL. So SSL all the way through. And then at the back end here, potentially you could do clear text if you wanted to. That's a configuration of the NGINX Ingress controller. So 2 personas. So the cluster, if we go back to the personas in this case here, the infrastructure provider is really out here. The cluster operators are really sitting right here. Cluster operators are right here, and the application developers are back here. So here is an example of the Ingress link CRD. You can see this is a kind of Ingress link. This is specifically written. This is in both of the API specs. This is also within the schema as well. The only thing that you really need to do is name it. Try to keep the namespace the same. It's actually just easier for yourself. Provide a IP address. If you don't want to provide an IP address, you can use IPAM, and that's perfectly fine. If you want to use proxy protocol, you can. You don't have to. And the name here is really important. This is the name for Kubernetes. This name will change for OpenShift, because for OpenShift it will be NGINX Ingress Operator. So just replace the name if you're using OpenShift. So what will happen is once you create this within Kubernetes, this is like 11 lines. Once you create these 11 lines, what will happen is CIS will populate BIG-IP. I know this is a little bit blurred. I do apologize. I pulled it out of the docs. And I do have this all written up. This is all written up. There's a GitHub repo. You can clone the repo. I will share that at the end of the slides. This is what will happen is this will be, pool members will be created, and you can see the pool members here. There's 4 replicas, and that's the proxy protocol. Again, this is all in the documentation that I will share at the end. So to go even more simpler, what we're going to do here is we're not going to deploy that CRD. We're going to simplify this even more. So we talked about the CRD here. In this next step, we're not going to deploy the CRD with an IP address. We're going to use something called service type load balancer. This is very common in cloud today, where the cloud provider provides the ingress and creates the service type load balancer. Now, how do we do this? We simply annotate the service. So it's exactly the same architecture. The only difference is the cluster operator doesn't necessarily need to create the CRD. The CRD is created for you by Ingress Link itself. And so let's take a look at what that looks like. So what you can see here is everything is created through the service. And this is the NGINX service that CIS is watching. CIS is subscribed to the service. Think of this as CIS's endpoint. And so we watch this endpoint, and we pull all the information from Kubernetes on that Kubernetes API to populate this endpoint. The difference here is of annotation, IPAM, test. Test, think of it as a label. So think of what test is, a range of addresses. And you can have many different ranges. This could be one IP, this could be a group of IPs. It's just a range. And so what happens here is that we specify this IP range, and we specify type load balancer. And what will happen is the IPAM controller will get and allocate an IP and update the status of that IP. So you can see right here, my IPAM label is of test, and that is the service, and there is that IP address. And this is stored in the IPAM controller. This is the BIG-IP IPAM controller. This is, again, fully supported. It can also be downloaded as well and utilized with the solution. So this really simplifies the solution, because the only thing you have to do is create the annotation and set up the IPAM controller. And that is kind of what you see right here. CIS interacts with IPAM. There's nothing you need to do here because the service is created, and that information would automatically get populated to BIG-IP. So this is the last solution. This is the last solution here. And this is really a question around what we talked about earlier. And this is something that we just released with CIS 2.8, and this will work with the latest version of the NGINX Ingress controller as well. And so I know there's a lot going on here, but our goal is to, think about it, is to leverage potentially BIG-IP DNS as well. And so this is where we're starting to really start to think about this solution. And this solution is totally going to evolve. We're having a lot of meetings internally. I am talking to a lot of customers across the United States. We're doing a lot of big room planning and a lot of meetings, both in Europe as well as Asia Pacific. And what's coming is actually some similar type of priorities for the specific use cases. In fact, I've got 5 use cases that I'm going to start pushing, and I've already started to scope the first 2 out for the next 2 up-and-coming releases. And let's talk about that. So in this instance here, I have now introduced DNS. And so we have our Ingress CRD that we talked about before. So think of the Ingress CRD as really the communication into the Kubernetes or OpenShift cluster. And so that's what you see right here. So that potentially is created by the cluster admin or the cluster operator, that Ingress CRD. So now we have what I call local traffic management, or we have a public IP, think of it as a virtual IP that is sending traffic to a BIG-IP pool. And within the pool, we have 3 pool members. That's great. Well, now I have rolled this out, let's say in San Jose, California. But now what I want to do is I want to roll out another cluster. Maybe it's a cluster that is in a different cabinet. Maybe that's the latest version of Kubernetes. Maybe this one version was 119 and I rolled out a version of 123. And what I wanted to do is I wanted to mirror these applications, but I didn't necessarily want to upgrade. Or if I did want to upgrade, I didn't want to take my environment down. Or maybe I'm doing a proof of concept with Kubernetes, but I wanted to do another proof of concept with OpenShift, and I wanted them to work side by side to kind of determine what do I like better. Maybe it's Rancher. Maybe one is a Kubernetes cluster on-prem, and the other one is a Kubernetes cluster that's hosted in your cloud provider. It really doesn't matter. This architecture right here is completely platform agnostic. But the key here is to integrate external DNS and to utilize BIG-IP DNS that a lot of customers are already utilizing today.